Let's look at some more rational functions questions. And we're going to focus on a new style where they've got a quadratic denominator. And obviously there's a little bit more going on here, because if there's a quadratic on the denominator, first of all we've got to think about asymptotes, vertical asymptotes, horizontal asymptotes. And in most cases, not all cases, but in most cases, remember when you think about your vertical asymptote, you think about when does the denominator equal 0. So if it's a quadratic, usually we'd get two solutions. But not always. Like, we'll see that some of them look different. Sometimes the quadratic will have no solutions, but for the first one we're going to look at a quadratic denominator where we get two vertical asymptotes, and then we'll think about the horizontal asymptote where it crosses the axis, and we'll draw a sketch. Okay, so I've just sort of piled all of a, b and c into one. Like if we're asked to sketch, same as with the other rational functions, think about your asymptotes, think about where it crosses the axis, and then we should have enough information to fill in the blanks and draw the sketch. Okay, so for the vertical, if we consider we can't divide by 0, so x squared minus 2x, when would that equal 0? Take a factor of x out, and we get two vertical asymptotes, x equals 0 and x equals 2. Similar thought process for the horizontal, it's just slightly different. Okay, so for the horizontal asymptote, remember that's as it approaches the horizontal asymptote, that's as x gets larger, as x approaches infinity. Okay, so as x approaches infinity, we could look at this, and really one way of thinking about it is that obviously if x is really big, that plus 3 isn't going to change anything, because in the old ones where they were just linear on the denominator, you just ignored your constants, didn't you? But think about it now, if x is really big, say for example if x was 1000, when you do x squared you would get 1,000,000. So this term here is far more important than all the other terms. So we can just look at the highest coefficient of x, and really we've got x squared divided by x squared, and all the other stuff isn't going to have much of an impact, because the highest power has the biggest impact, and that's as x increases, that's what it's going to tend towards. So a quick way of seeing this is just that y is going to equal 1. But to make sure we get the marks in the exam, and also some good exam technique for moving forward in other types of topics in further maths, if we think about this limit notation, like as it tends towards infinity, we can divide the top and bottom by x squared. So if we divide everything by x squared, we'd get 1 minus 4 over x plus 3 over x squared. X squared divided by x squared would be 1 minus 2x divided by x squared, so minus 2 over x. And then each of these terms, think about it as x gets bigger. If you're doing 4 divided by something big, it's going to get smaller. So all of those terms are going to tend towards 0. So if all those terms tend towards 0, we're left with 1 divided by 1. So our equation would be y equals 1. Okay. So we've got our asymptotes, now we just need to figure out where does it go through the axis. So let's say when x equals 0, y would equal 0. So 3 divided by, hang on a minute, 0. Okay, we've seen this once before, but not on the quadratic ones. If we get 3 divided by 0, that means essentially we've broken maths. Essentially that means that there's no solution here, so essentially we should just realise that it does not cross. Intersect. So if we set x to 0, we're thinking about when it crosses the y-axis. You might have already noticed that as well, like, why does it not cross the y-axis? Well, we already knew this at this point. You've got a vertical asymptote, which is your y-axis, so we know it's not going to cross the y-axis. Okay. When y equals 0, so now we're thinking about when y equals 0, when it's across the x-axis, we're going to get a fraction equal to 0. hopefully we remember what happens when you've got a fraction equal to 0. You want to multiply both sides by the denominator, but as soon as you do that, 0 times by this is left with just 0. So remember, whenever a fraction equals 0, it's just a numerator equal to 0. Solving this quadratic seems like it factorises, so x minus 3, x minus 1. So x would equal 3, and x would equal 1. Okay, so we've got enough information to draw our sketch. Okay, so one thing I forgot to mention, which I didn't copy down from the question, it also says in the question, you are given that the curve has no stationary points, and that's actually going to be quite important when we come to draw this. Okay, and we'll see why in a second. So we've got our vertical asymptote x equals 0 and x equals 2, horizontal y equals 1, and these are the two roots where it crosses the x-axis. Okay, so obviously give yourself enough space for your axes. 0 and 2, so I'm going to do a little bit more space over on the right hand side. Okay, so y equals 1. X equals 0. X equals 2. We've got a root at 1 and the root at 3. Okay, so we've got enough information to fill in our sketch. If you're still unsure at this point, you could sub in a couple of values, like you could sub minus 1 in and see if it's up here or if it's down here. You could sub in like 0.5 or 1.5. Okay. One other thing as well, I should mention about the graphical calculator, really useful for this topic. So if you press menu, graph, and then you can type in your equation. Okay. So to type in the x, it's this button, x d to t, so x squared minus 4x plus 3 divided by x squared minus 2x. Press execute and then F6 to draw. Now, you might think, well, that's not much use, I can't see the graph at all, but it's to do with your viewing window. So if you press F3 for viewing window, and then put it into standard, and then press execute, you get a much better idea about what's going on. Okay, one small drawback is you've just got to be careful here. Like, look what the graph's done. It goes up like this, and then it looks like it joins up. It doesn't cross that vertical asymptote. Okay, if we zoom in, hopefully it will fix that. Yeah, that's a much better picture. Essentially, all the calculator does when it plots these is it subs in values, and then it basically joins it subs in points and then joins the dots up. So if sometimes it gets a bit confused with the vertical asymptotes because it puts 1 point one side, 1 point the other, and it just joins them up. But if you zoom in a bit, you will see that that is actually an asymptote. Okay. So what if we didn't have these calculators? How would we have done this? Well, we need to have a vague idea about what the shape of the graph was anyway. And that's on the handout that we've given to you. But also, the fact that it says that the curve has no stationary points, see when it's in between these two vertical asymptotes, sometimes it'll have a stationary point and it'll be trapped in between them like a U shape, or maybe trapped in between them like an N shape. But if we've got no stationary points, basically that means that in between the two vertical asymptotes, if it's basically going to be an increasing curve or a decreasing curve, it's never going to curve back on itself. Okay, and the other thing as well, notice that in between these two asymptotes, there's no intersection with the x-axis. So in between these two asymptotes, I already knew that the graph was going to be up in that section there. Okay, so if it's up in this section, then it'll start down in this section, and it'll go up that way. And then finally we've got the fact that there's a root here, so we know it's in this section here. Okay, so let's just complete the sketch. Just make sure it gets closer to the asymptote but never crosses. Oh, right, sometimes people freak out a little bit at this point. So up until now in maths we've said, look, an asymptote is a line that the graph doesn't cross. So what we're going to do, just like miss a bit of the graph out and pretend that it didn't cross it? No. The honest answer is, for vertical asymptotes, the graph will never cross these. For horizontal asymptotes, maybe just pause and think for a second, why is it allowed to cross a horizontal asymptote? Like, what do we know about horizontal asymptotes? Vertical asymptotes, it's just clearly, like, if we sub 2 in, we break maths. If we sub 0 in, we break maths. But horizontal asymptotes, there's a different logic to that, isn't there? So why can't we cross the horizontal asymptote? Okay, so the reality is, the horizontal asymptote, that's what it approaches as x approaches minus infinity and as x approaches positive infinity. So as x gets really large, it approaches that number. As x gets really large, it approaches that number. You are allowed to cross a horizontal asymptote for small values, because in a small value, if you sub in a number in between 1 and 2, you do get 1 out as your answer. But as it approaches infinity, it approaches 1. So for the horizontal asymptotes, it can go through, but only for small values. It just tends towards those asymptotes for your large x values. Okay, so once we've got our sketch, the last part of the question. So this is how it's written. It actually says solve x minus 1, x minus 3 divided by x minus 2 less than or equal to 0. So obviously the first thing you have to realise is that, well, that function that we're working with is the same as this factorised version, like it's just factorised. So asking when is this less than 0 is the same as asking when is this less than 0. So let's look at our sketch. Less than 0, well, 0 is this line, isn't it? This is when y equals 0, that's this line. So for less than or equal to 0, this section of the graph here and this section of the graph here are the two sections when we're less than or equal to 0. Now be careful here. We're allowed to be equal to 0. So see that point there, 3. That's when x equals 3, the graph equals 0. So that is allowed. When x equals 1, the y value is equal to 0. So those 2 points are allowed. Let's think about our number line then. So we want these numbers in here and these numbers in here. So when x is between 0 and 1, well, that's when our answers are less than 0. Be very careful how you write this answer. Is it allowed to equal 0? No, it's not allowed to equal 0 because that's where our asymptote is. Is it allowed to equal 1? Yes. Because when we sub 1 in, the answer is 0. And it's allowed to be less than or equal to 0. Okay, this section in between 2 and 3. Is it allowed to equal 2? No, because that's your asymptote. Is it allowed to equal 3? Yes, because that's when it equals 0. Right, so that's our solution for this one, guys. Let's look at example 3, which is an exam style question on rational functions with quadratic denominators. We've got y equals 1 over x plus 2, and that's defined as the curve C. We want to find the asymptotes, and we're told that it's got exactly one stationary point. We will do some in the next couple of videos, we'll do some stuff on stationary points, but for now it's telling us where the stationary point is. So we know the x coordinate is -1, That's basically intended to help us with our sketch. If you know where the stationary point is, you can sketch it easier. Okay. Then sketch the curve and solve an inequality once we've got our sketch. So let's start with the asymptotes. Vertical. Remember, we can't divide by 0, so x plus 2 equals 0. We know that x equals 0 and x equals minus 2. Straight away you should be thinking, right, well if x equals 0, that's the y-axis, isn't it? So we know it's never going to cross the y-axis. So I don't need to figure that out before I do my sketch. For your horizontal, you've got y equals 1 divided by, so there's a constant on top. On the bottom we've got x squared plus 2x. And like you could just hopefully just realise that, look, if x approaches infinity, we've got 1 divided by something that's getting really big. And when you do 1 divided by something really big, y will approach 0, so the asymptote would be y equals 0. Alternatively, you can divide everything by x squared. That tends towards 0. But then you still get 0 divided by 1, so obviously you've got y equals 0. Alright, so our asymptotes are done. X equals 0, x equals minus 2, y equals 0. For part B, it says there's a stationary point and it tells you the x coordinates. So basically all this is saying is, look, x is minus 1, what's the y coordinate? Well, let's just find out. Sub in the x value to figure out what the y value is. So we've got 1 divided by minus 1 times by 1, so 1 over minus 1. So our stationary point is at minus 1, 1. Okay. Part C says sketch the curve, so the only thing I'm going to do here is figure out where it crosses the axis. Ah, right. Does it cross the axis? No. Okay. So we've got a vertical asymptote, which is the y-axis. We've got a horizontal asymptote, which is the x-axis. If we were going to figure out if it did cross the x-axis, if I tried to solve y equals 0, maybe you didn't spot this, you'd be solving 0 equals 1 divided by x plus 2. And as soon as you try and do that, if you multiply up, you get 0 equals 1. So there's no intercepts for this graph. Okay. So this is where the graphical calculator does come in really useful. So if I delete this, we can enter the sketch to check. We've got 1 divided by x. Oops. X plus 2. You might want to zoom out a touch. But just be careful, as soon as you zoom out it sort of breaks the vertical asymptote, but you can see the shape. So we're in this quadrant, and then we get this stationary point here, and then we're in that quadrant. If we zoom in, there we go. Really useful as well when you get used to these calculators. You can even check the coordinates for the stationary point. So if I do g-solve, we can see that that point there is a maximum point. It tells me the stationary point is minus 1. So you can even check your answer for part B. Okay, let's see what happens if I do g-solve root, because like the root is where it crosses the x-axis. It doesn't actually cross the x-axis on this one, but let's just see what happens. Not found. Okay. Right, so there's useful bit of advice to check with your calculator. And then we've got 0, x equals minus 2. We've got a stationary point at minus 1. Minus 1. So how, without the calculator, how would we know like what this looks like? Because if you've got a stationary point there, how do you know it doesn't go like this and turn and go back up, when actually it goes like this and turns and goes back down? The reality is we don't get any roots, do we? So if there's no root, it can't be up there. So we know it must be down in this section. Between these two asymptotes. and then it's in this section up here. And this section. So once we've drawn it, the last thing we need to do then is to solve our inequality. Okay, we're looking at the left hand side, which is y equals our curve. The right hand side, if we consider y equals 1/8. Again, don't, in terms of exam technique, draw out a new sketch. Don't draw it all over the sketch. Like if you're getting marks for this sketch, don't start drawing all over it like I'm about to do. Okay, but I'm being lazy, I'm just going to draw on this one. Y equals 1/8 would look like this. And we're being asked for when is the curve below 1/8. So here, we can see it's below 1/8. In this section it's above, and then in this section is where it drops below again. So it's going to be those x values there, it's going to be these x values here, and in this section it's below 1/8. So it'll be those x values. So we already know some of our solution. We know it's going to be in between -2 and 0. But we need to figure out when this value, so when x is bigger than this, it drops below 1/8. When x is less than this, it drops below 1/8. Okay. Again, we can use the graphical calculator. Don't just rely on this in the exam because you need to show your method. But if we draw y equals this, and then y equals 1/8 as well, and draw both of those, it looks like it's on the axis, but it's not. It's just because we've zoomed out. If we zoom in a bit, it might be easier to see. There's a point there where it intersects, and there's a point there where it intersects. So if I do, let me just zoom out again so they're both there. If I do gsolve intersect, it'll tell you, if you've got two separate functions drawn, it'll tell you the points where they intersect. So that value that we're looking for there is -4, and then if you scroll across to the other one, think about it for a second, that value there is 2. So let's just make sure we get the method marks. We can check our answer in a second. How would we figure out those values algebraically? Okay, so if we want to figure out where they intersect, we've got 1 over x plus 2 equal to 1/8. So we're just going to rearrange and solve this equation. Let's multiply both sides by 8 and multiply both sides by x plus 2. So we'll be left with 8 on this side equals, multiply that side, x squared plus 2x. Solve your quadratic, set it equal to 0. Factorise x plus 4, x minus 2, so x would equal -4, x would equal 2, which is what we've just checked on our calculator. So the last thing we've got to do is just write our solution. Remember, we're looking for when is the function less than 1/8. So it's these values, and these values. Be careful again, it's allowed to equal. So that point there is when it equals 1/8. That point there is when it equals 1/8. So we're going to write x less than or equal to -4. Or in between here, so that's in between -2 and 0. It's not allowed to equal either of those because they're the asymptotes. It's never allowed to equal them, the vertical asymptotes. And then more than 2. But it's allowed to equal 2. And there's our full solution. Okay, thank you.